Today we're going to talk about complex numbers. Complex numbers are any numbers the form of a plus bi, where I stands for the imaginary unit, and a and b represent real numbers. A complex number, as I said, is written in the form a plus bi. A and b are real numbers, and I represents that imaginary unit. The definition of the imaginary unit is the letter I, and I is equal to the square root of -1. So every time you see I, think of it as square root -1, and I squared then would equal to -1. Now let's go ahead and simplify some complex numbers. For example, the square root of -1 is not defined with only real numbers, but now that we have a definition for complex numbers, we can say that this 81 is equal to -1 times 9 times 9. So the square root of 81 is equal to 9, and the square root of that -1 is I. So the square root of -81 equals 9i. The square root of -16 then would equal to 4i, because 4 times 4 equals 16, and the I is represented because we have a negative radicand. Don't forget, if you have a number that's not a perfect square, you can still simplify that. The fact that the negative radicand exists means your I will be in the simplification, and then 12 is simply 4 times 3, and we know that the square root of 4 is 2. So you would write this as 2i square root of 3, since the 3 is that remainder factor. Now you can add and subtract complex numbers. For example, 3 plus 5i added to -7 minus 3i can be added together if you combine the like terms. Notice the real numbers will combine with the real numbers, so 3 plus -7 is really equal to -4, and 5i plus -3i is really equal to 2i. The solution then is -4 plus 2i. You can also subtract real numbers and complex numbers. Here let's look at 2 plus 6i subtracted 12 minus 3i. Many students would like to think of this as an understood -1 in front of that second parenthesis, so that subtraction applies to the 12 and the -3i. So in reality, you have 2 plus 6i subtracted 12, and when you subtract a -3, it becomes +3i. When we combine like terms, 2 minus 12 is -10, +6i plus 3i is +9i. Notice I am putting the I term last to be in the proper a plus bi form. You can also multiply complex numbers with the distributive property or the FOIL method. First, here is the distributive property. 3i times 5i is 15i squared. 3i times -7 is -21i. But remember, I squared is equal to -1 by definition. So this is like saying 15 times a -1, which is -15 minus 21i. That would be the final answer. To see the FOIL method, take a look at this. 4 plus 5i times 2 minus 3i. First would be 4 times 2, which is 8. Outer term would be 4 times negative 3i, which is negative 12i. So we have our first term and our outer term. Then you come back to the 5i. 5i times 2 is 10i. That would be my inside terms. Then 5i times negative 3i would be the last terms to get, which would be negative 15i squared. Combine the middle terms and you will get negative 2i. Replace I squared with negative 1, and that negative 15 times negative 1 is a positive 15. Now I can combine the positive 8 and the positive 15. I now have positive 23 minus 2i. Final answer. Last but not least, we'll talk about dividing complex numbers. When you divide a complex number such as 9 over 3 minus I, you must multiply by the conjugate of the denominator. The conjugate of any binomial term really is comprised of the same terms except a different middle sign. So the original problem was 3 minus I. I'm going to multiply by 3 plus I. In the top, the numerator, you will distribute 9 times 3 is equal to 27, and 9 times I is 9I. In the bottom of the fractions, the denominator, you will use the FOIL method. 3 times 3 is 9. 3 times I is 3I. Negative I times 3 is negative 3I. Negative I times positive I is negative I squared. Notice the middle terms will cancel out because they equal to 0. And I squared is the same thing as negative 1. So I have 9 minus negative 1, or that's the same as 9 plus 1 in the bottom. Now this is really 27 plus 9i all over 10. To be in the proper a plus b format, we need to separate this. So we will rewrite this as 27 tenths plus 9 tenths I. Final answer. Good luck on all of this complex number. See you next time.